Hey guys, welcome back. I am working on page M1-106 from your textbook, and the title of this is, of course, Solving Quadratics with Imaginary Zeros. So this is the thing that we've been working up to all week long, and that is find solutions when our functions do not cross the x-axis. So it says, consider each quadratic function, use technology to sketch each function on the coordinate plane, and label the function on your graph. So if you want to, you can plug this into your graphing calculator or go to Desmos to get real accurate sketches. But f of x equals x squared plus 9. So this function, I know right off the bat that the y-intercept is 9. So I have a point right here. The parabola is going to cross right there. And I also know that the a value is positive, that this function is going to be concave up. So it should look just about something like this. You should get something very similar to that, maybe more rounded out down here. Okay, so then, hey, g of x is in vertex form. Try to do this in a different color to distinguish this. So g of x is in vertex form, and it's telling me that I have a vertex at 2, 1. Remember, those h and k values tell you where vertices are at. So I would go over 2, up 1, and I can plot a point right here. The a value on this one is also positive, so that means it is concave up. So maybe this one's going to look something like this. Goes on forever, and then in this direction as well. Definitely not the best sketch at all. Hey, so then h of x, our last function up here, it's in standard form, and it's also got a b value, which changes things a little bit, but kind of the same story. We have a y-intercept at 2 and a positive a value, which means it is concave up. So this one would just go this way and go this way, of course, continue on forever. All right, hey, so what do the solutions of these three functions have in common? So here's our x-axis. That is where we find solutions. And you should notice that all three of these functions do not intersect the x-axis. So what does that mean for us is the solutions, or the zeros, or the roots, or whatever, the solutions are all imaginary. We will not get real solutions when we try to solve each one of these functions. Just as a side note, I guess, we can say that they do not, they being the functions, they do not cross or intersect the x-axis. That is where we find our solutions. They do not cross the x-axis, which means our solutions are going to be imaginary. All right, so number 3, consider the function x squared plus 9. Describe the structure of the function. How does it compare to the function q of x equals x squared minus 9? So q of x equals x squared minus 9. I can just write it out here. X squared minus 9. That is a difference of squares. That is a difference of squares. Difference of squares, because obviously x is being squared, and then 3 squared is going to give you 9. So it's really easy to factor out this function. Again, that's because it's the difference of squares. X squared minus 9 can be rewritten as x plus 3 times x minus 3. So hey, the function f of x equals x squared plus 9. X squared plus 9, that is kind of just the opposite. X squared plus 9, that is not a difference of squares. That is a sum of squares. All right, moving on to question 3, part B. Consider an equation written in the form ax squared plus c equals 0. So that's almost standard form, but there is no b value here. Complete the table to show when the solutions of a function are real or imaginary. So our first scenario here is the value of A is positive and the value of C is positive. So when that happens, your graph is going to look very similar to what happened here with f of x. Positive A value, positive C value, no B value. So anytime your function follows this rule, you will have imaginary solutions. You will have imaginary solutions. Now, if A was negative and C was positive, so going back up here once again, if this had been negative x squared, I would have had a function that was concave down. So my function would have went down like this and then down like this, and I would have solutions. So, or real solutions, I should say. So if C is positive, A is negative, and it's in this format, you will have real solutions. Now, what if A is positive and C is negative? So going back to this function, again, if this was negative 9, had I started down here, it still had a positive A value, I would have went up, and my solutions would have been real. I would have crossed the x-axis. And so the last one, if A is negative and C is negative, so hey, what that's meaning, or what that's telling you is, if you have to go down to get to your y-intercept, and the A value is negative, which means your parabola is concave down, again, you are not going to cross the x-axis, which means you will have imaginary solutions. Imaginary solutions. Awesome, that's going to do it for this page. Let's move on. Page M1-07. A lot going on here. Part C, if the factored form of difference of squares is a squared minus b squared equals a minus b times a plus b, what is the factored form for the sum of squares? Gosh, this is kind of rough here. You have to think about a lot of things. One of those is I squared equals -1. That's one of these important concepts. Very similar to this, honestly. So we're going to write this out as a squared plus b squared, right? So I'm kind of following this up here. It looks a lot like this, but we're adding in imaginary components. So it's equal to a plus bi times a minus bi. Okay, we'll work through this in just a second, and you can see why that's going to work. For part D, what are the solutions to f of x equals x squared plus 9? So of course, to find solutions, we are going to need to be setting this function equal to 0. So x squared plus 9 equals 0. I suppose that's one way that you could do it, is factor this out like this. I'm probably not going to do that. I think an easier way to try this is subtract 9 from either side of the equation. Hey, we'll get to x squared equals -9. Now, we need to cancel out this square. How we would do that is take the square root. So x is equal to the square root of -9. Now, if you try to evaluate this on your calculator, you are going to get an error. We can't take the square root of a negative number and get a real solution. So instead, we're going to rewrite this as, I'll do it over here, x equals the square root of 9 times the square root of -1. That's going to give us right back here to where we started. 9 times -1 for -9. Now let's work on evaluating this. So x is equal to the square root of 9 is 3. And just to keep track of this, we are still finding two solutions. So it's not just 3, it's positive or -3. I think you can see why that works. 3 squared is 9. -3 squared gives you 9, right? So any square root has a positive and negative component to it. Now this, the square root of -1, is imaginary. That was our imaginary number. So that would be the solutions to that function, positive or -3i. Okay, moving on. Number 4, consider the function g of x equals x minus 2 squared plus 1. how can you use the structure of the function to determine whether its zeros are real or imaginary? So this is not solving it yet. It just wants you to know or realize, what are my solutions going to be? And hey, so what that is, or how to find that at least, pick out the vertex. We know it's in vertex form, and the vertex is going to be at 2, 1. We also know by the a value that this function is concave up. So what you could do is sketch a very quick graph and just see, will this cross the x-axis? If so, I have real solutions. If it does not cross the x-axis, I have imaginary solutions. So hey, the vertex, I would have to go over 2, up 1, and like I said, it's concave up, so I would just go like this. So you can see just by looking at this that you are going to have imaginary solutions. And this is really the question that you're asking yourself when you're given a function in vertex form. Do a quick sketch and just see, does it pass through the x-axis? Does it cross the x-axis at all? If it does, it's real. If it does this, or it does not cross the x-axis, your solutions will be imaginary. All right, so let's try to solve this one. What is the solution to x minus 2 squared plus 1 equals 0? So we can use kind of the same strategy that we just used up here. Just use square roots to do it. So first step could be subtracting 1. I'm just trying to work towards my variable. So x minus 2 squared equals -1. Now to get to my variable, I am going to have to cancel out this square. How you cancel out squares is taking square roots. Square root of a square just kind of goes, cancel each other out, which means I have to square root the other side of my equation. So I'll square root -1. Now what am I left with is x minus 2 equals positive or negative I. Please remember that when you are square rooting something, you have both a positive and negative solution there. Awesome. Hey, so then let's keep going here. X minus 2 equals positive or negative I. The last step would just be to add 2 to each side of your equation. And how you write this matters. You want to get the order correct. You want the real part in front, the imaginary part in the back. So hey, x is going to be equal to, since 2 is the real part of my complex number, I'll write this out as 2 plus or minus I. Okay, that's it for when you have a function in vertex form. Let's keep moving on. Question 5, consider the function h of x equals x squared minus 2x plus 2. What is the most efficient method to determine the zeros? Explain your reasoning. Well, one thing you can do is try to find the factors of 2 that add up to -2. And that's going to be impossible. You're never going to find any factors of 2 that add up to -2. So really the most efficient method is to use the quadratic formula. Quadratic formula. Hopefully you guys are starting to memorize this now. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so in this quadratic formula, in order to get imaginary solutions, I would have to be taking the square root of something negative. If I did b squared minus 4ac and I got something negative, then I'm guaranteed to have imaginary solutions. So hey, this thing in the radical, b squared minus 4ac, that is known as the discriminant. So if you're checking for if you're going to have real or imaginary solutions, when you're given a function in standard form, the easiest way to check is find the discriminant, the stuff inside this radical sign. All right, so for part B, determine the discriminant of the function. How can you use the discriminant to know whether the solutions are real or imaginary? All right, so the discriminant, if your discriminant is positive, if the stuff inside the radical is positive, you will have real solutions. If the value inside of the radical, if the discriminant is negative, well, what's going to happen? You will have imaginary. You will have imaginary and or complex solutions. All right, fantastic. Maybe we try this on the next page. Flip it over here. So question 5C. What is the solution to x squared minus 2x plus 2 equals 0? Well, like I said, we are going to use the quadratic formula to do this. So I'll try to start working on it over here. X equals negative b. My b value is negative 2. Plus or minus the square root of b squared. Maybe I can show you what I'm doing. I got a here, b there, and c here. Minus 4 times the value of a, which is 1, times the value of c, which is 2. All that is going to be divided by 2 times a. 2 times 1. Okay, so just start working through this. It just becomes simplification. So x equals 2 plus or minus the square root of. So negative 2 squared is actually 4. It is not negative 4. Anytime you square a number, if you square a number, it is going to be positive, no matter what. If I square something negative, it is going to be positive. If I square a positive number, it's positive. Squares are always going to be positive. So negative 2 squared is positive 4. And then minus 4 times 1 is negative 4. Negative 4 times 2 will give me negative 8. All going to be divided by 2. I'll keep working through this. X equals 2 plus or minus. So 4 minus 8 is going to be negative 4. All divided by 2. Now, the square root of negative 4, we're going to have to deal with that. Again, so the discriminant was negative. Inside of the radical sign, we evaluated what was inside of it, and we got a negative number, which means our solutions are imaginary. So we can still work with this, though. The square root of negative 4 can just be rewritten as 2i. So hey, an easy way to think of this is the square root of 4 is 2, and the square root of a negative number is imaginary. All right, so now we got to deal with this. Easiest way to think about what's happening here is this is getting divided by 2, and this is getting divided by 2. Everything up here is being divided by 2. So x is going to be equal to, well, 2 divided by 2 is just 1. I've got plus or minus. 2 divided by 2, that's also 1. So I don't really need to write that because I know I have the I. So 1 plus or minus I. All right, fantastic. 1 plus or minus I. That would be the solutions to this equation. I just did all of this right there. So x equals 1 plus or minus I, just to make it clear. Describe how you can check your solutions. Well, what you would have to do is plug in the solutions for x. Plug in the solutions for x. So what I mean by that is you could check your work by doing 1 plus I squared minus 2 times 1 plus I plus 2 equals 0. So hey, when you evaluate this, when you work through this, and you simplify everything on this side of the equation, you should get a 0 as a result. It should say 0 equals 0 when you're all done with it. But just to save you some time, I'm not going to do that in this video. 6 and 7 are kind of the same thing. Rewriting this in factored form, really not too concerned about. You just replace these roots with with these solutions, the 1 plus I and also 1 minus I. Again, I'm not worried about having you guys solve things in factored form. Quadratic formula is definitely the easiest way to go about it. For why you wrote the function, in fact, I mean, they're equivalent, algebraically equivalent. That's the point of these different forms. They can be equivalent to each other. All right, so let's move on to the last question here. Question number 8. Use any method. It says use any method to determine the zeros of each function. So zeros, again, are just the same thing as solutions. Now, I'll work through part A with you. Any method that you want, you could try to find factors of positive 18 that add up to negative 8. Remember, you can always do that. Well, actually, let me rewrite this and set it equal to 0. Negative x squared minus 8x minus 18 equals 0. Now, what you can do to make the a value equal to 1, that way you don't have to deal with this negative sign, is move everything over to this side. So like you could add x squared, add 8x, and add 18, and just see if that's easier for you. So you do the same thing to this side of the equation, add x squared, add 8x, and add 18. So this stuff, it's all going to cancel out, and I'll be left with x squared plus 8x plus 18. So now you should see pretty easily that it's not going to be able to be factored because I have a positive c value. I got to go all the way up to 18, and then for my y-intercept, I have to go all the way up to 18, and my parabola is concave up. So that should tell you with pretty good clarity that we're probably not going to have real solutions. The method that I would use to determine zeros, when you give a function like this, is just use the quadratic formula. So x equals negative b, which a is 8 in this case, plus or minus the square root of, so b squared minus 4 times a times c, all divided by 2a. So just keep working through this. It just becomes simplification now. Negative 8 plus or minus square root of, so 8 squared is 64. Negative 4 times 1 is negative 4. And negative 4 times 18 is negative, pretty sure it's 72. And that'll all get divided by 2. Okay, keep working through this. Negative 8 plus or minus the square root of. So 64 minus 72 is negative 8, all divided by 2. Keep on going. X equals negative 8 plus or minus the square root of 8i. The square root of a negative number is imaginary. And if you try to do square root of 8 on your calculator, you're going to get this decimal that never ends. And then this is all divided by 2. I'll work with you in class during one of our live sessions on how to simplify the solution, but for now, we'll leave it there. Okay. Hey, so for the next 2 questions, I want you to work on these before you come to the live session. And I will work through these 2 functions with you during that live session. So hey guys, thanks for watching, and I'll see you in class. Bye-bye.